Algebra, it's Mr. Mock, and we are going to tackle the Module 4 notes, which is covering more factoring. And I've got three pretty good examples here for today. We're also kind of, wrapping up our polynomials, content. And the Khan Academy, or not the Khan Academy, the Pearson work that I had assigned is really a review. It's kind of going over quite a bit of things. So, this is just the last part of this unit before we kind of move on and do some other stuff. But I wanted to go over these three examples because it's a little bit different, a little bit tricky. But again, it goes back to that kind of like that problem solving that we had done last week with the factoring. Kind of like solving a puzzle, which is kind of fun. So when you look at it, the first example, whenever you start with factoring and you're trying to break down a problem, always look at the numbers, the coefficients, the numbers in front of the variables, and see if they right off have a common factor. Okay, so for this particular example, I have x cubed, x squared, and x. So I already know I can factor out an x. Okay, I can factor out a single x. I can take a single x from this term, and this term. Okay, at the same time, I know that 6 can go into 30 and can go into 24. So my very first step is to factor out something from each of the terms. In this case, I can factor out a 6x, okay? If I divide out a 6x from 6x cubed, it's going to leave me with x squared, right? 6x times x squared is 6x cubed, all right? Now, if I divide 30 by 6, that's 5. If I divide out an x from x squared, that leaves me with an x, right? Because 6x times 5x is 30x squared. And then I look at the 24x. 24 divided by 6 is 4, and when I divide out an x, it's just going to leave me with 4, right? So I took this crazy and factored out something that they all shared, the 6x, which now leaves us with this trinomial, right? We can factor that. That's what we did last week, right? So we're looking at factors of 4 that add up to 5. Well, that's just 4 and 1. So 6x. And then remember this, we immediately kind of go this route. Factors of 4 that add up to 5 is just that guy right there. And so what we appears to be kind of like a bigger crazy, you just take it bit by bit. First step, always look at what are the coefficients? Can I simplify something out there? And you're only doing whole numbers. Don't take fractions. Don't do fractions. Don't break it down to decimals. Another form of a fraction. Don't take parts of numbers. Just stick with whole numbers, integers, right? So we were able to take the 6 out, and then we had something easier to break down, all right? So you're going to have something like that to work on in the Pearson work. The second example is a little bit different. This one, if you immediately look at the coefficients, or in this case a constant, there's no common factor. All right, so we're kind of left with, oh my gosh, what is this? Like, what do I do with the 10x squared? This is a little bit crazy. So what we're going to do here is kind of break down this problem. And it requires us to, we're going to split this 17x somehow. And here's how we do that. We want to split the 17x. Split the 17x by multiplying the 10 and 3, which is going to give us 30, okay? So now we want to do factors of 30 that add up to 17, and I'll show you why. Factors of 30 that add to 17. Now, guys, this is going to blow your mind, and I really need you to have your thinking caps on. This is something you really need to process and figure out, okay? Factors of 30 that add up to 17. So we have 6 and 5. 6 and 5 is 11. That's not going to work. 3 and 10. That gives me 13. Getting better. Guys, check it out. 2 and 15. Do you see that? 2 and 15. So here's how this is going to work. I'm going to go ahead and I'm splitting the 17x into 15 and 2. So I'm going to do 10x squared plus 15x plus 2x plus 3, okay? And then what I want you to imagine is that you're taking this and splitting it into two binomials and looking to see how you can factor it, all right? I can factor out a 5 from each of these terms, right? As well as an x. Do you see how both those? So I'm taking the left side, factor the left side, then factor the right side, okay? So I can factor out a 5x, which is going to leave me, when I divide 10 by 5, I get a 2, and I'd get an x. And then, excuse me, 15 divided by 5 is 3, and okay, sweet. Oh my gosh, check this out, right? So now plus, and then over here, I can factor out a 1. 2x plus 3. And do you see how, and this is the key, you know you've done it right when this and this are the exact same. That is your objective. Because we have 2x plus 3 is the exact same on both sides, we can now factor this out, okay? This, we can factor out the 2x plus 3. And then the 5x plus 1 becomes its own factor, and we just factored this bad boy right there, okay? Now, Mr. Mock, that seems like a lot of extra steps. It is. But look, you've got this 10 as the leading coefficient, and we need to consider that. So we multiply the leading coefficient with the constant, and then find factors that add up to the middle. And then do you see how we use that to split it up? All right. Now, how did you know, Mr. Mock, to put the 15 here and not the 2? Well, I looked and thought, well, if the 15's there, I'll be able to factor something out to get to this. I did some pre-thinking, okay? So, you could have put the 2x there, actually. I think it would have worked, now that I look at it. Actually, in fact, would have worked if you did it the other way around. But when you want to check your work, 5x times 2x is 10x squared. 1 times 3 is 3. 5x times 2x is 10x. I'm sorry, 5x times 3 is 15x. 1 times 2 is 2x, 15 and 2. And look at that, it works. So you can check your work, yippee skippy, okay? Takes us to the second one, or the third example, okay? Third example is the same thing. You want to go ahead and multiply the 2 and negative 21, which is negative 42, and you want to do factors that add up to, not 0, there's 1x there, add up to 1. So I need factors of negative 42 that add up to 1. All right. So now we break this down. What are some factors of negative 42? Well, 2 and 21, and that doesn't work. 2 and negative 20, no, that's not going to be close. I need two numbers that are like just one away from each other, right? So using my multiplication skills, wouldn't that be 7 times negative 6? 7 times negative 6 is negative 42. 7 plus negative 6, there you go, right? So let's go ahead and put this all together. Let's split this up. I'm going to put 2x squared, and why don't I do the minus 6 here? Why not? So minus 6x plus 7x minus 21. All right. And then, you know, I'm going to go ahead. I'll bring out, I'm not ashamed, no shame in my game. I'm going to go ahead and bring this out to remind myself that I'm splitting those two up so I can factor the left side, factor the right side. So what do I have in common here? I can factor out a 2 as well as an x. So I'm going to factor out a 2x, which is going to leave me with x minus 3, sweet potatoes. And then on the right side, what can I factor out here? A 7. 7 can go into both of those. So I'm going to factor out a 7, but then it's going to leave me with x minus 3, and boom, yay, look, I know I did it right, because I have the x minus 3 together, right? That means I can move that over as one piece. And then, what do I do? I used black again. This one, boop, 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 and boop, boop, boop. What is here? There's a plus, that's a positive 7, so it's going to be 2x plus 7 right into that space, and boom, I factored it. How do I know? 2x times x is 2x squared. 2x times negative 3 is that negative 6x plus 7x, and cha-ching, I got my x. Okay, so I always double check it. Guys, do the best you can. Get into Pearson. Do that work. Send me questions. There's a lot of review that we're doing this week. Challenge problem, I just want you to come up with something that is interesting, creative. You know, have fun with it. Make a problem and then solve it. You know, that's your challenge problem for the week. If you need some help, contact me. We can do a Google Hangout. I can give you that one-on-one time. If you have some questions at the end of the rotation, stick around. I can answer your questions there. But it was awesome seeing you this past week. I look forward to seeing you guys at rotation this week. And just keep up the great work, team. You're really doing a fabulous job considering everything that's going on right now. And I really appreciate you guys. Stay well, and I'll talk to you soon. Bye.